Hello, welcome to our third part of our series on algebraic expansion. If you haven't seen the other videos, please make sure to check them out. And today we're going to be going over some more advanced concepts in algebraic expansion and some shortcuts as well. So to begin with, let's review a little bit of what we saw in the last video. When we have two what we call binomials multiplied by each other, we can do what simply works as a distributive property to expand this. So you would take this parenthesis, multiply by this term and this term, then you would get 2x plus 3 times x, and there's a multiplication here implied, plus 2x plus 3 times 4. I'm going to write out the multiplication here. And then we would do this distribution to complete the expansion. So we would get 2x times x plus 3 times x plus 2x times 4 plus 3 times 4. And then you could combine like terms, we have a video on that as well. But anyway, this is how you would expand this. However, this takes a lot of time if you look at this, and there's a much quicker way actually to do this, which a lot of people call FOIL. There's actually, Abdul made a video explaining how this acronym works. It's going to be linked right here and in the description if you want to check that out, but I don't even use this acronym a lot, so I'm just going to show how it works conceptually. So if we have the same expression here, remember this is an expression because there is no equal sign, so there's no specific value for these variables. They're just like placeholders. So here, instead of going through all the separate distribution, you can actually do this kind of like pattern or multiplication. And so what this means is you would multiply this first term by both of these and the second term by both of these. So in the end you would get 2x times x plus 2x times 4 plus 3 times x plus 3 times 4, which I'm just gonna write 12 because we're running out of space. And as you can see, this is actually exactly what we got here, just with some quicker steps. And so this is what we would call FOIL, and if you look at it, it's just the same process that we did here. We ended up just multiplying each term by the other two in the other multiplication, in the other parenthesis, but this is just a quicker way to look at it. So remember this pattern, multiply each term by all of the others in the other parenthesis. And now let's go through an example where it's not just two terms, two numbers added together. Now you have one parenthesis that has 3 of them, and it actually works exactly the same way. So here you can do again this distribution to each term, but I'm just going to skip to this process, which would be multiplying again each term of this parenthesis by each term of that one. So x times 2x, and here as well. So first we have x times 2x plus x times y plus 4 times x, x times 4, the same thing, plus 2x times 1, which is just 2x. You can just write out 2x, right? And again, 1 times y is just y. Then 1 times 4 is just 4. And here, I'm going to do the combining like terms this time, so you would see like what would be the complete process in this. So here, 2 times x, well first let's write out these multiplications in simpler ways. 2x times x can be written as 2x squared, right? Exponent, there are 2 x's being multiplied, so we can write it as x squared. Here, xy, it's just implied multiplication, plus 4x plus 2x plus y plus 4. And now we can look at here, what are the like terms that we have? We have 4x and 2x, here 2 of them that have the same variable with the same power. Both of them are x to the power of 1 here instead of 2. So we can add, if you have 2 x's and you want to add it to 4 x's, how many x's do you have? In the end, 6 x's, correct? And then I believe there are no other like terms. Yeah, no. 2x squared plus xy plus y plus 4. Again, you can combine them. We have a video on that if you want to check that. So this would be your final expanded expression. Okay? And so this is how algebraic expansion works. This is very useful in certain situations where, I don't know, where it's useful to have numbers added together instead of multiplied. It's a very useful strategy, to keep in mind. And yeah, and remembering just that you are not, changing the actual value of this expression, because again, it's an expression, so the variables don't have any specific terms. You're not doing any change to this, you're just rewriting it in a different way, but it just simply means the same thing. If you plugged in then numbers for x and y here and here, you would get the same final answer, and I recommend you to check that out by yourself. Anyway, okay? So, yes, any questions, you can send an email to us. Thank you very much.